Hi guys, this is Mr. Crowther here, geometry teacher, and we're going to pick up off the Desmos activity that you've just completed. We're going to go through some of the vocabulary, how it's used, and ultimately end with the three important trigonometric ratios to take away from this introductory lesson to trigonometry. So we're going to start off with the fact that we have special words to describe the sides of a right triangle. The one that is the more complex of the three, the one you may be the most familiar with, is called the hypotenuse. The hypotenuse is always the side opposite the right angle, and it is always the longest side in a right triangle. So none of the other two sides will be longer than the hypotenuse. In this drawing, you can see it is labeled in orange, and it is represented by side AB. The other two sides are actually going to be referred to as the legs of the triangle. They will be referred specifically as the opposite and adjacent legs. And these legs are labeled in relation to an angle. These legs can change names depending on where the angle is. We'll get into that in a little bit, but let's look at the first, what is called the opposite leg. And the opposite leg is always across from a given angle. So if we're looking at angle A as our given angle, the opposite side would be side B, because side BC, as side B is across from angle A. We say it is the opposite side. It is opposite angle A. Side BC would be labeled as the opposite side. This would leave us with one final side, and that is referred to as the adjacent leg. It is the non-hypotenuse side that is next to the given angle. Again, in this case, using angle A, side AC would be the side that is adjacent to angle A. The adjacent side is also the side that forms angle A with the hypotenuse. So your adjacent side and your hypotenuse will form your given angle. So from the perspective of angle A, this is how we would label triangle ABC. Again, orange, the hypotenuse, that longest side, the diagonal side. The opposite side, side opposite across from angle A, and the adjacent side, the side that is next to angle A. Now, if we were to look at it from a different perspective, the perspective of angle B, you'll notice the hypotenuse hasn't changed. Side AB is still the hypotenuse. What has changed are the sides labeled adjacent and opposite. Because side B is now at the top of the triangle, the adjacent side, the side that is next to angle B, is side BC. The opposite side, the side that is across from angle B, is now side AC. So I'm just going to flip back so you can see the difference. Angle A, referring to this angle down here. Adjacent is at the bottom and opposite is on the left. When I change my perspective to angle B, adjacent's on the left, opposite's on the bottom. The hypotenuse did not change. It will always remain the longest side of the triangle. That's why it's really important to understand what the reference angle is. So the reference angle is the angle that we're using to solve for the missing pieces of a right triangle. In most cases, you'll be given or told which angle is the reference angle, but there will be some cases in which you have all the angles of the triangle, or you have the ability to determine all the angles of a triangle because you know they sum to 180 degrees. So you could use either of the two angles. And when I say two angles, I'm referring to one of the two acute angles, the angles that are less than 90 degrees, that are in the right triangle. Obviously, one of them is going to be 90 degrees. The reference angle will be one of the two acute angles. And again, that'll either be given to you, or you can determine the missing angle, or you'll have all three angles. But determining which angle you're going to use as your reference angle will be very significant as we go forward. So quick check. Using angle G as our reference angle, or relative to angle G, which side is the adjacent side? I'm going to give you about 5 seconds. All right, hopefully you guys all were able to come up with the fact that with angle G as my reference angle, that side MG is my adjacent side. So given this right triangle, angle X is my reference angle, how would you label the sides? The first thing that does not change, the longest side right here, that will be our hypotenuse. Because angle X is here, I have two other options, the opposite and the adjacent. Again, the opposite side will be across from angle X. So angle X is my reference angle. The side that's across from angle X will be my opposite side. And finally, my third, the side that is next to angle X, not the hypotenuse, that's the adjacent side. So hopefully you're starting to understand how to label a right triangle based on the reference angle. So let's take a look at this example. I got triangle ABC. We will indicate that it is a right triangle by putting our right triangle mark there. So if my reference angle is angle C up here, so I'll call X. Angle C is my reference angle. How would I label the sides? For me, and as you go through this, the easiest side to find will be the hypotenuse. It is the side that is opposite the right angle and always the longest side diagonal. So side AC would be my hypotenuse. Now the opposite side, again, is across from the angle, the reference angle. Again, we're going with angle C. This has a degree measure of X. It's unknown. The opposite side is going to be side AB. It is across from angle C. And finally, that would leave the adjacent side, the side that is next to angle C, but not the hypotenuse. In this case, side CB. So why is being able to label these sides very important? Well, that jumps into the trigonometric ratios you were introduced to in the last Desmos activity. And just as a refresher, those ratios are sine, which is abbreviated SIN, cosine, which is abbreviated COS, and tangent, which is abbreviated TAN. Some of you at this point are starting to put things together because you've seen these buttons on your calculator. Sine, cosine, tangent. And these ratios are derived from certain sides of the triangle. So let's look at the sine ratio first. The sine ratio is comprised of the opposite side and the hypotenuse. So based on our reference angle, in this case, we have the Greek letter theta indicating our reference angle. The sine of theta would be the opposite side divided by the hypotenuse. That is the ratio that divides sine for all right triangles. So in the yellow box, you'll see the ratio written out. You'll also see the abbreviated ratio, which you'll sometimes see, as well as the super abbreviated ratio as sine of theta equals O divided by H. And it's important to remember that there is something after the sine, and that is the angle. That's what that theta represents. So if we have the same angle measure in multiple right triangles, as we've talked about in similar right triangles, the angles stay the same, but the sides could change in proportion. The sine value isn't going to change as long as we have that same angle. So for every right triangle that has a reference angle of 30 degrees, the ratio of the opposite divided by the hypotenuse will be the same. And hopefully that's one of the takeaways you got from the Desmos activity. The second ratio is the cosine ratio. It is defined as the adjacent side divided by the hypotenuse. So over in the green box here, we have the cosine of theta, again, theta being our reference angle, as the adjacent divided by the hypotenuse. You're abbreviated and you're super abbreviated. And finally, tangent. Tangent is defined as the opposite side divided by the adjacent side. So if our reference angle down here, theta, our opposite side divided by our adjacent side. Abbreviated, super abbreviated. And there's a great mnemonic device that can help you remember these three ratios. I've always learned it as SOHCAHTOA. I've heard it pronounced as SOHCAHTOA. But again, it has been a great reference and is used throughout the geometry world as a way to remember the three ratios. So let's break it down. SOHCAHTOA is three parts of three letters. SOH, the S-O-H, refers to the first trigonometric ratio. So SOH is sine equals opposite over hypotenuse. Ka, the second three letters, refers to the cosine is equal to the adjacent over the hypotenuse. And TOA, the last three, refers to the fact that the tangent equals the opposite over adjacent. So SOHCAHTOA, SOHCAHTOA, is a mnemonic device that will help you remember the ratios for each of the three trigonometric ratios we'll be using: sine, cosine, and tangent. All right, we're coming to the end. We'll wrap this up with a couple of examples using numbers so you can see how they play out. So I have my triangle over here, triangle CAT, C-A-T. I have, in this case, all my sides labeled, and I know all my angle measures. So if my reference angle is angle C, and I want to find out what the sine of the 36.9 is, sine refers to as opposite over hypotenuse. So the opposite side length is 6. The hypotenuse is 10. So my ratio would be 6 over 10. So the sine of 36.9 is equivalent to 6 over 10. That can be reduced down to 3/5, or it's a decimal point 6. The cosine of 36.9 degrees is going to be the ratio of the adjacent to the hypotenuse. So in this triangle, the side length of the adjacent is 8. The hypotenuse, once again, is 10. So the cosine of 36.9 is equivalent to 8 over 10. As a reduced fraction, that's 4/5. As a decimal, it's 0.8. And finally, tangent. Tangent, in this case, of the 36.9 degree reference angle is equivalent to the opposite over the adjacent. For this triangle, that would be the opposite side is 6, the adjacent is 8. So it forms the fraction 6/8. Reduce that, you get 3/4 as a decimal, 0.75. If we look at the other perspective, using reference angle T, the 53.1 degree angle, things change a little bit. The sine, again, is the opposite over the hypotenuse, but the opposite is now down here. The opposite is now 8. So the sine of 53.1 is equivalent to 8, the opposite side, divided by the hypotenuse, which is 10. Simplified down now, it's 4/5 as a decimal, 0.8. The cosine will be the adjacent side, which is 6, divided by the hypotenuse, which is 10. So the cosine of 53.1 is equivalent to 6/10. As a reduced fraction, 3/5 as a decimal, 0.6. And finally, the tangent is your opposite divided by adjacent. The opposite side is 8. Your adjacent side is 6, so we have 8 over 6, which is a reduced fraction is 4/3, or as a decimal is 1.3, repeating 1 1/3. So hopefully this has been a good introduction for you. You understand how to label the sides of a right triangle, what a reference angle is and how it can change the meaning of the opposite and adjacent sides, and how we are going to use it with numbers going forward. At this point, you can go take the exit ticket and submit it to your teacher and finish up this lesson. Thank you for listening and watching.